Hey ladies and gentlemen, sorry I couldn't be there today. I got called to a meeting, but hopefully you had a good weekend. We're going to try something new today. We're going to do a video lesson. I'm going to ask that you basically just follow along if you go with your notes as well, or watch the video, fill in the notes later. But I wanted to make sure you had an opportunity to get some instruction even though I wasn't there. Before we do the lesson, we are going to start with a bit of a fun warm-up here. You see that on the right-hand side, there is a triangle that's actually broken down into many smaller triangles. So what I want you to do is take a minute here, and I want you to figure out, or do your best to figure out, how many total triangles there are in the picture. I'm going to ask that you pause the video for just a second while you count, and then when you have your answer, go ahead and resume the video. Okay, so let's see how we did. We'll start by counting the smaller triangles. We can see that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 small triangles. Now, we also have a larger set of triangles. If we combine, and so we can see that's outlined in red, we have one of those, 2, 3, 4, 5, 6, plus this upside down one of the same size here, 7 of those. After that, clear this out so we've got some more room to work with. We've got this larger size triangle. 1, 2, 3 of those. And then lastly, we have the large overall 1. So in the end, our final answer is that there are 27 triangles. Okay. Now, as far as today's lesson goes, it is going to be on something that you should all be relatively familiar with, and that is the Pythagorean Theorem. This is something that you should have learned last year, maybe the year before, maybe even earlier while you were in middle school. So just as that quick reminder, the Pythagorean Theorem says that in any right triangle, it has to be a right triangle, the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. Now, this is a lot of words for a very simple system that we know as a squared plus b squared equals c squared, where a and b are the legs. In other words, they are the two perpendicular sides that create the 90-degree angle. C represents the hypotenuse every single time. The hypotenuse can always be found by drawing that arrow from the right angle box. The hypotenuse is always the largest side of the triangle. It is always across from the 90-degree angle. So C always has to be the hypotenuse. A and B are interchangeable. So this could be A and this could be B, or this could be B, this could be A. It has zero impact on the outcome of the problem. What's most important is that the hypotenuse is C. So anytime we have two sides of a right triangle given to us and we're looking to find the third, we're going to use the Pythagorean Theorem. The most important thing, again, is that we identify which side the hypotenuse is. So we look at this first example here. It asks us to use the Pythagorean Theorem to find the length of the missing side. In this case here, I see I have a 10, I have a 16. I check, do I have the hypotenuse? And I don't. Therefore, I'm going to try to solve for c squared. As far as the other two numbers go, those are my a and my b. Again, it doesn't matter, so 10 squared plus 16 squared is equal to c squared. Now, at this time, I would just go right to the calculator, and I would type in 10 squared plus 16 squared, press enter, and that's going to come out to be 356. And lastly, since this is c squared, I want to know what c is, so I'm going to take the square root of both sides. When we do the square root of 356, that's going to simplify to 2 root 89 if you are using one of the yellow calculators. If you're just using one of the calculator apps or a different calculator, you're going to get an answer of 18.87. Okay? Either one is all right. Okay. So, in this case, we were given the two legs. We found the hypotenuse. In the next example, though, slightly different. In this case, we are given the hypotenuse. The most common error I see on a question like this is students will do 22 squared plus 51 squared is equal to c squared. Obviously, that's incorrect because we know the c value. The c value is 51. So we do not want to write c squared there. We do not want to write 51 there. We know that c is 51, and we're just going to leave that as b squared. So 22 squared plus b squared equals 51 squared, or again, you could say a squared plus 22 squared equals b squared. Either one is fine. Now in this case, our goal is to solve for b, that missing side. So treat it like any other algebraic question. If it makes it easier to think about, get rid of the squareds. If it were just 22 plus b equals 51, we would subtract 22 from both sides. But it's 22 squared, so we're going to subtract 22 squared from both sides. At this point, I go to the calculator, and I would do 51 squared minus 22 squared. B squared comes out to be 2,117. Last step, again, take the square root of both sides. B is equal to 46.01. This one does not simplify. So either answer is acceptable. Okay. Now, we've seen an example in which we did not know the hypotenuse. We saw an example in which we did. Please take a moment on your own to try this example 3. Please pause the video. Once you are done with the work, go ahead and resume the video to see if you were correct. In this case here, we can draw our line across from the 90-degree angle and we see 55. 55 is the hypotenuse. Therefore, 33 squared plus b squared is equal to 55 squared. The hypotenuse is 55, so that's our c squared value. Everything else we just treat like the example from before. Subtract the 33 squared from both sides. B squared is equal to 55 squared minus 33 squared. That comes out to be 1,936. Final step, take the square root of both sides. So the square root of 1936 is exactly 44. So these are just our generic or our basic Pythagorean theorem style questions. The next type of question is what we call a Pythagorean triple. So by definition, a Pythagorean triple is a set of 3 non-zero whole numbers. So again, 3 numbers, none of which can be 0, that satisfy the Pythagorean theorem. By satisfy, that means that when we plug them in, we get a true statement. So an example of a Pythagorean triple is 3, 4, 5, because when we plug those in, this algebraic equation is true. 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, 5 squared is 25, and if we were to do that quick addition on the left side, we get 25 is equal to 25. So 3, 4, 5 is a Pythagorean triple. In other words, the sides of 3, 4, and 5 create a right triangle. So when we look at examples 4, 5, and 6 here, and 7, we want to know, do these three sides given create a right triangle? So what we're going to do is we are going to plug them into the Pythagorean theorem, and if the two sides are equal to each other, then yes, it does create a right triangle because the Pythagorean theorem worked. If it does not equal the same thing on both sides, it is not a right triangle because the Pythagorean theorem did not work. So in this particular case here, we want to identify the biggest side. The biggest side is 8. That means this is my C value. Therefore, 5 and 6 are A and B. So I want to know, does 5 squared plus 6 squared equal 8 squared? If it does, it's a right triangle. If it doesn't, it's not. 5 squared is 25. 6 squared is 36. 8 squared is 64. 25 plus 36 is going to be 61. 61 is not equal to 64. Therefore, the sides 5, 6, and 8 do not create a right triangle. When I try the second example, 7, 24, 25, 25 is the largest number, so that's my C. Does 7 squared plus 24 squared equal 25 squared? 7 squared is 49. 24 squared is 526 or 576. And 25 squared is 625. Lastly, when I do the addition on the left side, 49 plus 576 comes out to be 625, which is 625. Yes, the three sides, 7, 24, and 25, do create a right triangle. Okay. At this time, I'm going to ask what I've been asking before. Please pause the video, take a minute or two, however long you need, to try examples 6 and 7. When you have your answers for each of those, please resume the video to check your work. $25 is the largest value, so this should be 15 squared plus 21 squared. We want to know, does this equal 25 squared? 25 squared we already did in the problem before, so this was 625. Now, instead of breaking these two down into each individual piece, there's no reason why you can't just do 15 squared plus 21 squared in your calculator at the same time. And that comes out to be 666. These two are not the same. 15, 21, 25 does not make a right triangle. Our last example, 9, 40, 41. 41 is that C value. So 9 squared plus 40 squared. Does that equal 41 squared? We go to the calculator. 9 squared plus 40 squared comes out to be 1681. 41 squared is also 1681. These two are the same. The Pythagorean theorem is satisfied. Yes. 9, 40, 41 does create a right triangle. Okay. Last thing you'll be asked to do is be able to solve a couple word problems involving the Pythagorean theorem. So, as we read through, we should understand that each one is going to be some sort of right triangle. I would draw a picture and label it accordingly to represent the wording in the diagram to help make things more appropriate. A 12-foot ladder is leaning up against a building. The bottom of the ladder is 5 feet from the building. How high up the building is the ladder touching? So, if we can visualize a ladder is leaning up against a building, there's our building, this is our ladder. So the bottom side of our right triangle is just going to be the ground. Now, it tells us that it's a 12-foot ladder. Therefore, on this side, I'm going to put a 12. The bottom of the ladder is 5 feet from the building. So from the bottom of the ladder to the building, that distance is 5 feet. We want to know how high up the building is the ladder touching. So we want to find this height. We have two sides of the right triangle, 5 and 12. We're looking for the third side. So our first check is, do we have the hypotenuse? And we do. So that's going to be our c squared value. 5 squared plus b squared is equal to 12 squared. From there, we do our subtraction. Go to our calculator. 12 squared minus 5 squared is 119. So we take the square root of 119. And that does not simplify. If we wanted to turn it into a decimal, that comes out to be 10.9 feet, or 10.91 with rounding. Okay. Either one is acceptable. If you want to leave it as the square root of 19, you can do that. If you want to convert it to a decimal, you can do that. Okay. Next question, similar context, but looking for something different. A cat is 18 feet up in a tree. If the bottom of the ladder needs to be 7 feet away from the tree in order to remain balanced, will a 20-foot ladder be tall enough to retrieve the cat? So this is a yes or no question. Will a 20-foot ladder be enough? Okay. So we've got our tree. We've got our cat that's stuck up in the tree. And we know that the cat is 18 feet up in the air. We know that the bottom of the ladder is going to be 7 feet away from the tree. We want to know, will a 20-foot ladder be long enough? So in order to do this, we have to figure out what that hypotenuse is. We do not know, so this is just going to be 18 squared plus 7 squared is equal to c squared. Go to the calculator. 18 squared plus 7 squared comes out to be 373. Last step, take the square root of both sides to get c by itself. So the square root of 373 comes out to be 19.31. So ultimately, the question wants to know, will a 20-foot ladder be tall enough to retrieve the cat? Well, we need a 19.31 foot ladder in order to get there. So yes, 20 feet will be long enough. Okay. Now, for these last two, if you'd like, go ahead, read through, draw your diagram, set up your Pythagorean theorem, solve. When you have your answers, go ahead and resume the video and check and see how you did. Question 10 says, a baseball diamond is a perfect square with 90 feet between each base. How far is second base from home plate? So, it's a perfect square in which it is 90 feet around. Because it's a perfect square, we've got 90-degree angles. The question wants to know how far it is from second base to home plate. So home plate would be in this bottom corner. Second base goes across the way. And we can see that by doing that, we end up creating a right triangle on both sides. I'm just going to focus on this one on the right-hand side. we want to know what that distance is from home plate to second base. Therefore, I've got two sides. I want to find the third. I don't know what the hypotenuse is. 90 squared plus 90 squared is equal to c squared. Okay, when we do 90 squared plus 90 squared, we end up with 16,200 feet is c squared. Final step, take the square root of both sides. And we get 127.28 feet. And that is our distance from from home plate to second base. For our last example, TV measurements are based off the length of the screen's diagonal from the bottom left to the top right. So there's the TV. If a 65-inch TV, so again, that means from the bottom left to the top right is 65 inches, is 34.1 inches tall, so from top to bottom, 34.1 inches. How wide is the TV? Right angle is going to be in the corner, so our Pythagorean theorem shows us we will have the hypotenuse, so we'll set that equal to 65 squared. 34.1 squared plus b squared is 65 squared. Subtract 34.1 squared from both sides. And b squared is equal to 3,062.19. Last step, take the square root, and we get 55.34 inches as the width. If you have any questions, be ready to ask them, or feel free to ask them tomorrow during class, or you can shoot me an email and I'll do my best to get back to you as soon as I can. There is a homework assignment available in Schoology, so please make sure you go in there, get that done. You have the rest of the hour to do that. Once it gets submitted, you are done for the day. Thank you for watching. I hope this helps. Have a great rest of your day.